Okay, welcome everyone to Math 426. I'm going to try this out, see how recording the videos lasts, and if this works out pretty well, all of the courses will be recorded in this way. So first of all, we're going to finish off the notes that we started last day, and then we'll have a little quiz partway through the class, and then we'll add up some more notes, and then we'll assign homework assignment. So these are some examples of some like terms. You see here 2a squared and negative 8a squared are like terms because they both have a squared in them and they both have a coefficient in the front. These are another pair of like terms, 3ab squared. So your variable combination is ab squared, and you have ab squared, and they both have a coefficient in the front. So these are like terms. The next one, 3/4 x squared y squared and 2x squared y squared. Again, this is another pair of like terms. You have x squared y squared, you have x squared y squared. So those makes those like terms because they have the same variables with the same exponents, same combination of variables with the same exponents, and they each have a coefficient in the front. So each of these pairs of like terms have identical variables, either a squared, as we said, ab squared, or x squared y squared, where each variable has identical exponents. Like terms can be added or subtracted. In the first case, 2a squared plus a negative 8a squared, or 2a squared, removing the brackets, minus 8a squared is negative 6a squared. The second example, 3ab squared plus a negative 8ab squared. 3 plus a negative 8 is negative 5. And then you have the same variables, ab squared. The last set of like terms, last pair of like terms, they can be subtracted. So you have 3/4 x squared y squared minus 2x squared y squared. To subtract here, you have to have the same denominator. So you have 3/4, you have 2/1. So you need the same denominator, so you need 4 on the denominator for this 2. So you can convert 2 to 8/4. Now, since the denominators are the same, 3/4 minus 8/4, 3. When you're subtracting fractions, you keep the denominator the same, and you add or subtract the numerator. So 3 minus 8 is negative 5, negative 5/4, and the variable stay the same, x squared y squared. So since each of these pairs are like terms, they can be added or subtracted, whatever the circumstances is in the given case. Here's some more polynomial examples. So another polynomial, you have this polynomial. This is an example of a polynomial, x plus y plus 4. X is one term, y is another term, 4 is another term. You have 3 terms, therefore makes it a polynomial. 3 different monomials in the single expression makes it a polynomial. Another polynomial here with 3 different terms, x squared plus a xb squared plus a. 3 terms, 3 monomials connected with plus signs makes it a polynomial. Another example of a polynomial, b to the third plus a squared plus 4/3 r squared. Another polynomial made up of 3 monomials connected with plus signs. Each of these expressions is called a polynomial. A polynomial is non-like monomials linked by addition or subtraction signs. A polynomial with 2 terms is called a binomial. One with 3 terms is called a trinomial. So, just finish your questions, and then I'll write the next. I'll give you the answers in a minute. I'll just walk around the class. I'll pause the video now for a moment and give you time to go through these questions. I'll just hit the pause here and I'll start the video again. the answers. So just go through, and you would written these on a separate sheet, so just correct them, put your name on the top, make sure the number of the course is on the top and the date, and correct these, check each one, and I'll collect each sheet. Again, I'll pause this to give you check them. Don't change your answers, please, and write what you got out of 7. Also, polynomials can be represented geometrically. In this case, coming up, you see any squared terms. In this case, x squared is represented, we saw notes on this before, where it's represented by a box. So you have 2x squared. So since they're like terms, they can be added. So you have 2x squared represented by 2 boxes. Now you have 3 bars here, each the same, representing an x. So you have 3 bars, so you have plus 3x. Next, you have 4 small squares, each representing 1. So you have 4 of them, so it's plus 4. So finally, you're representing 2x squared plus 3x plus 4 is represented here geometrically with these drawings. Another example, let's look at an example of a binomial. So it has 2 terms connected by a plus or minus sign. So you have, look at the x's, there's 1, 2, 3, 4, 5 of them. So one kind of variable here is an x, and it's represented, notice, by a bar. And you have a negative y. Notice, since it's negative, we represent here. Last time with the notes, we shaded it. Well, here it's a negative, so it's shaded gray. So you're representing, this represents the binomial 5x, because there's 5 of them, minus 2y. This is 2 monomials joined by a negative sign, so you form a binomial. It has 2 different terms. Let's look at this monomial of degree 3. So you have an x cubed. You have degree 3 because the sum of the exponents in the variables, in this case there's only one variable, so the sum of the exponents is 3, shown here, x to the third. You have another x to the third, represented by another 3-dimensional cube, another x to the third, and then you have another x to the third. So 3x to the thirds, since they're like terms, they can be added. You have 3x to the third. These are like terms and therefore can be added to form a single term. These are like terms, so in other words, the cubes are all the same shape, so they can be added up. And a single monomial is formed and expressed as 3x squared. Let's look at this, another polynomial, and let's look at this one. You have 2x to the third cubes, in other words, the exact same size and shape, so they're like terms, they can be added. There's 2 of them, so it's 2x to the third. You have x squared, there's 3x squared, they're represented by large boxes, so there's 3 of them. They're like terms, so they can be added, so it's 3x squared. You have 2 x's, and these should be represented as bars, so I'll make that correction and just make it, and I'll show it to you later on in the slides, minus 2x, and since they're grade, so they're negative. And then there's 5 units for constants, so there's 6 of them, so it's plus 6. So you have an example of a polynomial. Polynomials can be formed using 1 or more variables. In this example of a polynomial, we have 2x to the third plus 3x squared minus 2x plus 6. There are 4 terms here, or 4 monomials. This polynomial uses only the variable x. You see there's x here, x here, x here. Again, this polynomial is made up of 4 monomials, 2x to the third, 3x squared, negative 2x, and plus 6. Each of these monomials that I'm pointing to is called a term. The terms in a polynomial appear in decreasing order of degree, and this is what I mean. If you look at this polynomial, 2x to the third plus 3x squared minus 2x to the 1 plus 6. Normally you don't, this 1 is understood and is normally not shown, but I've shown it here for demonstration purposes. Notice that the exponents on the variables, or the degree of each term, the degree of this term is 3, the degree of this term is 2, the degree of this term is 1. This has no degree because it's a constant. It's the numbers, the degrees of the terms are decreasing from left to right. So in other words, the terms in a polynomial occur in decreasing order of degree, from the largest down to the right to the smallest. The constant term, of course, is last, where there is no degree. And as I said before, the exponent on 1 on 2x is generally not shown. That 1 is generally not shown. This one here, this polynomial is made up of only a single variable. So you notice that it only has an x. So the term is 2x to the third, this term is 3x squared. But there's only a single variable, only a single type of variable, that is x. So only the variable x is present. And the polynomial is symbolized by this symbol here, p brackets x, uppercase P brackets x. So that symbolizes a polynomial of only a single type of variable x. There's only x present here. The next example, a polynomial with variables x and y can be symbolized by this p brackets x comma y. This is an example. P brackets x comma y, so it's a polynomial having an x variable and a y variable in various combinations. You see 2y x to the third plus 3x squared minus 5xy plus 4. There's 2 types of variables, x and y. So notice that the variable x and y are both present in the polynomial, symbolized by this p brackets xy. For a polynomial, the degree of the polynomial, when you're looking at the entire polynomial made up of several 2 or more terms, the degree of the polynomial is the degree of the term having the highest degree. And this is what I mean. So for the polynomial having variables x and y, the degree of this term is, you add up the exponents, 3 plus 4 is 7. The degree of this term is, there's only x in here, so the exponent is 2. So the degree of this term is 2. The degree of this term is 2 also, because you see that x has exponent 1 and y has exponent 1, so the degree is the sum of the exponents, which is 2. So you say the degree of the polynomial, you look at the term having the highest degree, which is this one, 2x to the third, y to the fourth. That's the degree of your polynomial. So the degree of this polynomial is 7, since the sum of the exponents on 2x to the third, y to the fourth, 3 plus 4 is 7.